up to high power level, up to several kilowatts power level. And one of the problem of the resonant converters when you're doing the frequency control is that you do not have the optimum point to control it. Because what happens is that in order to get the 0 voltage switching, you must operate your converter above the resonant frequency. But we don't know what resonant frequency is, because resonant frequency is changing as function of load, and resonance frequency is changing because of the variation in the component. So I was very lucky to have Professor Humberto Pinheiro as my PhD student, and he worked on the something called self-sustained oscillation control of resonant converter. So in the self-sustained oscillation control of converters, what happens is that you do not have the external frequency controller. Your frequency is self-controlled. Then if your frequency is self-controlled, then basically you always operate it just above the resonant point. And by doing that one, there are two things happen. One is that your frequency variation is narrow. You limit the change of the frequency. And other thing is that you get lot of additional power at the output, because now you always operating closer to the resonant point. So you get more power output and with the same size of the circuit. So that is one of the advantage of the self-sustained oscillation control, and it's all due to because of Dr. Pinheiro. And afterwards, I had a couple of other PhD students who followed on this SSOC work, and then refined further. And one of the recent work we have done is that we have implemented this one in the digital control. So it was not an easy task to convert it from analog to digital. So, but we have now converted it successfully in as a digital control as part of this electric car solution. Actually, you met one of my students last year, right? Mazin, and he is the one who basically converted that into digital tech. So these are some of the advantages which I had just mentioned. And these are some of the simulation results here for this one. So you have very nice input current in phase, and then you have the 0 voltage switching. And we have some of the other graphs in terms of the efficiency and other things. So we are able to reach over 96% efficiency in most of the load rate for this DC converter, and we can perhaps hit 97, 98%. And these are the three different kind of converters. And actually, this is a old picture. Unfortunately, my computer crashed week before I was coming, so I cannot bring some of the latest pictures. So in the latest picture, all these three converters have the same side, same mechanical config. Okay, they all look same. And as you see, these are not simple converters. They have a lot of magnetics, a lot of capacitors, a lot of things inside there. And I think in conclusion, the new resonant and soft switching conversion techniques are basically now being employed in prototypes to develop a urban electric car, and we expect that this will play a major role in the future. And one of the things basically what we try to do here is we try to minimize the use of external components. So like the passive component. So anything we try to do is that try to find a solution through the semiconductor, so that the semiconductor can be packaged and then you have a very one nice device basically. Okay. And other thing what we have done is that we are no longer using any analog control. All the control is the digital control, because this again basically helps. It helps us in implementation, right? Because now you can have only one controller, and one controller basically can control all the three converters, right? So and this control is nothing. It's just a FPGA, right? It's a one FPGA. You can bury all your codes and everything in one FPGA, and then one FPGA you have, and then you have other things, only the power module, right? You have the semiconductor devices and the power module, and all other components which you have, passive component, they have been minimized. They are very small. So because if let's say this concept gets into the use, right? Then so you will have the millions of parts. So we have to look into the like how can we simplify the product design for the future, right? So that is one of the driving factors, the simplification of design and the cost, right? And of course, this project was funded from a semiconductor company, so they wanted to see more of semiconductor solution than anything else. Okay, so that will conclude my presentation, and thank you very much. If there are any questions, I'll be happy to answer.
Any question? Who is the person? Yourself?
Initially, I'd like to thank Dr. Jain for a very nice presentation, and then just to warm up the question session.
Okay.
You make a very. I would like to know from you what is this power rating of this battery charger that you consider?
The power rating of the battery charger is between 3 kilowatts to 6 kilowatts, depending on the requirements. So it's between 3 kilowatts to 6 kilowatts. But I think what is happening is that, which I have not shown in my presentation here, that is the because of the smart grid, and one of the problem with the electric vehicle is that they're going to burden the power system considerably, right? Because you have to charge all the cars and everything, right? So one of the things is that you will charge this car during the night time when the power grid doesn't have much load, right? Then other thing is that if you take a typical electric car, the energy storage you have in this car is about in the neighborhood of about 20 kilowatt hour. So every electric car has about 20 kilowatt hour storage, which is battery storage. So now we have millions of cars, right? And if you multiply this number, then you get hundreds of gigawatt stored capacity which is available to you. And one of the problem with the renewable system is the continuity of the power, right? How do you store the power, right? So now what happens is that if you can use the electric cars as the storage, and then you can basically release the energy whenever you want, right? So then your electric car have dual use. One is basically, of course, for driving, another thing basically to meet your intermediate requirements, right? So those requirements are coming, and if those requirements are coming, then the design of AC-DC converter is very different. So now the AC-DC converters now have to become